So on these problems here, there's two rules. I'm actually going to do the rules first. Last couple of times I've worked an example first and done that. There are essentially two rules when you're doing division properties of exponents. The first rule and the main one is if you're dividing powers with the same bases, subtract the exponents. On last week when we did this, we did multiplication, you added the exponents. So when you divide, you subtract the exponents. It makes sense. Okay, when you do division, you add it. When you multiply, when you multiply, you add. When you divide, you subtract. Or ask yourself, where do I have more and how many more? The idea is if my denominator is larger than my numerator, I want my answer in the denominator. One of the things that we never want to have in our final answers are negative exponents. We do not want negative exponents in any of our final answers. So if I look at the first problem, 4 to the 5th divided by 4 cubed, I think about this. Okay, this is 4 to the 5 minus 3 power. 4 squared. That's the idea. Doing subtraction, not a problem. You just subtract the exponents. The one below that, same idea. 12 divided x to the 12th divided by x to the 5th is x to the 7th, because 12 minus 5 is 7. Easy peasy, right? The next one, yeah. So this one's a little different because I have my denominators larger. Okay. I have two choices. And kind of it depends on how you want to think about this. You can say, all right, this is c to the 4 minus 7, which gives me c to the negative 3 power. Which is right. Except we don't want negative exponents. So to make that a positive exponent, we would have to take that and make that 1 over c cubed. The other possibility, and this comes from this down here, is, okay, just subtract and put your answer where the larger exponent is to begin with. What's bigger, c to the 4th or c to the 7th? C to the 7th. So I still subtract 7 minus 4. 7 minus 4 is 3, but because my bigger one's in the bottom, that's where my answer would be. Okay, so you have a choice. You can do it either way. Just do the straight up subtraction, boom. Or you can say, all right, I'm going to subtract the exponents, and I'm just going to put my positive. Take the bigger exponent minus the smaller exponent, put my answer in the denominator or numerator as appropriate. And that works too. Okay? So we've got a lot of rules. This is the new one. When you divide, you subtract the exponents. Okay. And we will review all the rules here in a minute. Okay. It doesn't matter what kind of exponents we have. If we have a fractional exponent, we have a fractional exponent. So what? We still just subtract. So my problem here is x to the 3 halves minus 1 power. 3 halves minus 1. Well, 3 halves is 1 1/2. 1 1/2 minus 1 means that I have x to the 1/2 power. And yes, we do use fractional exponents. By the way, the fractional exponent, that's the square root of x, same thing. 1/2 square root, same thing. Then I go to the next one. It got more stuff. Not a big deal. Just look at it in parts. Do the m's first. M squared divided by m to the fifth. So, 5 minus 2 is 3, so I get m cubed. But where is it? It's my denominator because that's where my larger one is to begin with. So I have m cubed in my denominator. Do my m's, do your n's. N to the 4 minus 3. 4 minus 3 is 1. I get n to the first, and it goes in my numerator because that's where my bigger power is. So I have n to the first. Easy peasy. Any questions so far? If you understand the rules of exponents and you can learn the rules of exponents, follow them, this stuff's actually really easy to do. Right. Now, so I look at this next one here. This is very, very, very similar to what we were doing on Tuesday. On Tuesday, we raised things of power to a power, but it was all multiplication. This is division. It doesn't matter. If I'm taking x cubed over 5 and I'm cubing that whole thing, that is x cubed over 5 cubed. I just cubed the numerator and cubed the denominator. That's all. We got a fraction cubed. I just cube everything within that fraction, no matter where it is. So x cubed, what we did on Tuesday, when you raise a power to a power, you multiply the exponents. So I get x to the 9th. And for our purposes, go ahead and leave that as 5 cubed. If you wanted to work that out, that would be 125. If you want to leave it as 5 cubed, I'm okay with that. So try the next one. Okay. This is simple. Everything inside gets squared. So I have 2 squared, a cubed squared, b squared, squared. What's 2 squared? 4. That's an easy one. I would prefer that you make that 4 rather than leave this 2 squared because it's a simple one. When I raise a power to a power, I multiply them. So this gives me a to the 6th. And this gives me b to the 4th, or my denominator. Piece of cake, right? Raise a power to power, you multiply the exponents. Yeah. I have a negative 2 exponent. I have a couple of choices how to deal with this. I got a couple of choices on how to deal with this. I can do what we just did. Take the negative 2 power to the 2 things that are in here. That would give me x to the negative 2 over y to the negative 4, because I would multiply the exponents. But we're not allowed to have negatives in our answer, so what do we have to do? We take the x, put it in the denominator, make it positive power, take the y, move it up to the numerator, and make it a positive power, and that would be our final answer. Or, and this might be easier, in this case I think it would be, if we have a fraction to a negative power, flip the fraction over and change it to a positive power. You can do that. Flip the fraction over, change it to a positive power, because that's negative means do the reciprocal, which means 1 over an object. Or if it's already a fraction, you just flip that fraction over. And then square both sides, which will give me y to the 4th over x squared. And look, it's the same answer. It's the same answer either way. Which one I choose to do depends upon how complicated the stuff inside the parentheses are. This is actually pretty simple. I'd probably flip it over and then square everything. If it were much more complicated, then I would distribute the negative 2 and then deal with negative exponents after that. Try the one next to it. Ooh, appetite salmon. Interesting. Okay, because the inside of this one is relatively simple, everything in particular, everything inside has positive exponents. What I would do on this one is flip it over. So I have y to the 4th over 2x to the 6th, and change the power from negative 3 to positive 3. And then cube everything inside. So that means I have y to the 4th cubed over 2 cubed over x to the 6th cubed, which means y to the 4th cubed, I multiply them, I get y to the 12th over 2 cubed, which is 8. If you wrote 2 cubed, I'd accept that, but it is 8. And then 6 times 3 gives me x to the 18th. If you distributed the negative 3 first and then flipped everything over because it was negative, you'd still get the same answer in the end. Okay? Any questions on that? Okay. Now, to get ready for your skills test, here's what I'd like you to do. On the bottom of either the first page or the second page, I don't care which, copy the problems. You do not necessarily need to put zero powers, negative powers, multiplying the same basis. It would be a smart thing to do. But I do want you to copy this, 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 and this, all in the space either at the bottom of your notes, on either the page we just got done, or on the previous page. Do that now. Copy those problems down. Okay, so these are all the rules of exponents we have learned so far. Pretty much covers almost everything anyways. It's not a whole lot. There's a few more rules, but this covers pretty much almost all the rules of exponents. We've learned pretty much all of them by this time. There's a couple more, but I don't know, how much we're going to get into those. So the first one, the zero powers. Anything to the zero power is 1. So x to the 0 is 1. Negative exponents. I move them down into my denominator or I move them up into the numerator. So this would be x cubed, and this, would be 1 over x cubed, and this would be x to the 5th. Okay. Next one, multiplying with the same bases. What do we do to the exponents when we multiply to the same bases? We add all the exponents. So 7 plus negative 2 is 5, plus negative 3 would give me x squared. 7 plus negative 2 plus negative 3 gives us 2. Okay. When we divide, we subtract. X to the 15th divided by x to the 18th. 15 minus 8 gives us 7. We subtract, but if our answer larger powers in the denominator, our answer goes in the denominator. 20 minus 5 is 15, but our larger one's in the denominator, so we get 1 over x to the 15th, not 5, 15. And then the last one we have here, when we raise a power to a power, you multiply the exponents. So this is x to the 12th. 4 times 3 is 12. Now, we have here one last example. And this is an example that will help you on your skills test. Simplify it down. I have a's to a bunch of powers. I should be able to bring that down to a to 1 positive exponent by following these rules. Don't do it all at once. It's very difficult if you look at it to do it all at once. It looks, oh my God, it's overwhelming. But if you break it down and do it part by part, it's a piece of cake. So what I do is I go, all right, first thing I'm going to do is take care of this right here. A to the 5th cubed. Take care of the power to the power first. So that means I multiply them. So that part gives me a to the 15th. I did not change anything else. That was the only thing that I changed to my first step. I did one thing. I didn't do anything else. I did one thing. Don't try to do everything at once. Do it one part at a time. That would be the first thing I would do. Now, work on just the numerator. I am multiplying a to the 15th times a to the 20th times a to the negative 3. So what do? Is I add those exponents. 15 plus negative 20 is negative 5. Negative 5 plus negative 3. I get a to the negative 8 in my numerator. And then I do the same thing in the denominator. I just multiply it. I add the exponents. A to the 5th, a squared. A to the 7th. Step by step, it's a piece of cake. Try to do it all at once, it's overwhelming. Last step, I got one thing left to do. Take care of my division. Now, what's bigger, 7 or negative 8? 7 is bigger than negative 8. So my answer is going to go in the denominator. I'm going to have a to some power. I have not yet decided that power, but I'm going to have a to some power. What do? I subtract 7 minus negative 8. I do 7 minus negative 8. When I'm subtracting a negative, that's the same thing as adding a positive. 7 minus negative 8 is 15. So 1 over h to the 15th is my final answer. Because 7 minus negative 8 is the same thing as 7 plus positive 8, right? Change your subtraction to addition and do that. Piece of cake. Questions?